All right, so let's consider this problem. I'm going to draw my free body diagram. And again, I'll start with just a line drawing. There's the section from A, B, and C. Now at A, we'll assume that's a pin. It looks like a pin. So at a pin, I'll have two unknowns, AY and AX. Now, how are we going to deal with this thing BD? Since we've talked about it briefly before we started the problem, this is since there's no load applied here, this is going to act like a two-force member or like a truss element. So this is the line of action of the force. So we know the direction, we just don't know the magnitude. So I'm going to go ahead and draw it that way. I'm just going to assume that that force is just called B, and it's in that direction. And if you look at the angle, this should be 30 degrees. So you can see there's 1, 2, 3 unknowns. It's statically determined. Now the next thing I'm going to do is let's look at our applied loads. If you do come over here and imagine this split into a rectangle and a triangle, let's deal with the rectangle first. What's the area of the rectangle? What's base times height? The base is 9, the height is 2. So that means I would get an equivalent force for that section right in the middle of, what was it, 9 times 2, 18? Now, and that takes care of this part of the curve. Okay? Now, what about the triangle part? Well, the area of a triangle is 1/2 base times height. What's the height over here? It's not 4. It's 2. So 1/2, 2 times 9 is 9. And that happens in the centroid of the triangle, which is 1/3 the distance from the big end. 1/3 of 9 is 3. So I'm going to transfer those over to my section. These are not to scale. So there's my 9 kilonewton force, 3 meters from A. And then I've got my 18 kilonewton force. And let's see, that's going to be 4.5 feet, right? So how if I just add another 1.5 feet inside there? That look okay? That way everything's measured from A. What would be the distance from here to B? Another 1.5, right? 3 plus 3 should give me 6. And then we don't really care about this part, but I'll go ahead and put that there's 3 out there. Everybody see that? Now also to make it easier on myself, I'm going to go ahead and calculate these components. So I know that this is B times the sine of 30 degrees, right? And this one will be a little harder to see. Color may help. That's going to be B cosine 30. Everybody see that? So I just broke it into its x and y components. So when I sum forces, x and y, I'll know the piece. And even when I sum moments about certain points, I'll know what to consider and what not to consider. So what do we do with this free body diagram? Can we sum forces in the x direction and get an answer? No, if I sum forces in the x direction, I'll have ax plus the x component of b equals 0. One equation, 2 unknowns. How about sum forces in the y direction? No, same thing. Got ay plus the y component is b, 2 equations, 2 unknowns. So I need to sum moments about some point. Which point would be best? A. I think A will be better. Now you could sum moments about B also, and that would give you a Y. but I think I would rather sum moments about A and get my value for B. So let's do that. So again, right-hand rule for my sign convention, and I'm going to sum my moments about B and make sure they're in equilibrium. So let's start. So summing about B, both my applied forces are creating positive or negative moment. It's 50-50, positive or negative. Positive. I like positive. I think that's the best answer. Because they are going counterclockwise around it. So starting with the first one, I have 18 kilonewtons, and it has a moment arm of 1.5 meters. And then I have 9 kilonewtons. It has a moment arm of 1.5 plus 1.5 is 3. Then what else? AY passes through B. Don't have to worry about that. Oh, I have AY. Yeah, I'm sorry. I mean AX passes through B. AY creates positive or negative moment about B. Negative. And what's its moment arm? 6. So we should be able to solve for AY. 4.5 and 3, 9. I'm guessing. Is it 9? Like the German 9, like 9? Or is it? Yes, it's 9.
Yes, it's 9.
Thank you.
Yeah.
9. Oh, someone speaks German. Ah, Mr. Mills. You're in the U.S. military and you speak German? What part of the service are you in? Okay, so that's 9 kilonewtons. And it came out positive, so we got the right direction. Now what?
I have a question.
Yes.
The reason why you took the moment about B was because, could you explain that real quick?
You could take the moment about a couple places that would help for you. I just did it about B for no particular reason, really. I could do A or B. I just chose B.
Or should I say, how did you know you could take it?
How do you take it about B?
I mean, how you know you could take it?
I can sum moments about any point I choose. So I chose a point at B because B passes through it.
Okay.
So B will create no moment about B.
Yeah.
So then I'm just left with everything else. Also, AX passes through B. So AX and B are concurrent at B. So I found a point where 2 of my unknowns were concurrent. That left just one unknown.
Okay.
The same case can be made for A. I don't know why I did that. You should get the same. I mean, you should be able to solve for B if you did that.
Yeah.
I may not want to. Okay, so now I can. What can I do now? Can I sum forces in the x direction? No, because I still have AX and B, but I can sum forces in the y direction. So let's do that. So I'll assume up. Y. So what do I have in the y direction? I have AY acting up, which I know. I have the y component of B, which is also acting up, which is B sine 30. Then what else do I have?
Minus 9.
Right, I have my 2 applied forces both acting down. So I should, if I plug this into here, I should be able to solve for the force at B. Someone's going to have to help me with that. Looks like the 9's cancel. I got 18. What's the sine of 30?
Say inverse sine of 8.
Thank you. That was very helpful, Mr. Copeland.
I got it.
Is it 0.5?
Well, the sine of 30.
Yeah, so that would be half of, so what do I get?
9. You get 9?
No. Get 36, right?
36, yeah.
Because it'd be 18, divide both sides by the sine of 30, you get 36. And it comes out positive. So I assume the right direction. We talked about it before. I just assumed with all these forces acting down that this link would have to push up to balance it, so I assumed it was acting up. Okay, so now I have everything I need. I can now go finish this problem off by summing the forces in the x direction. Let's see what we've got. We've got AX, don't know AX. And I have B cosine 30. And I know B. You can plug that right in there. I think that's it, right? So what's AX? Whatever 36 times 0.866 is. What's that? Anybody happen to know that off the top of their head? 31 point what? 31.17. That's kilonewtons. And I got a negative value. Right? So that means AY is actually acting to the left, which seems reasonable. So any other questions about this? No? All right.